In this video here, we're going to be talking about the quadratic functions and doing an example that involves a quadratic function. So we're given a quadratic function here. We're going to find the vertex, decide if it's a minimum or a maximum. We're going to find the x and the y-intercepts of the graph. We're going to put the graph in the other form of a quadratic function, the vertex form, and we'll end up with actually sketching the graph of this quadratic function after we get all this other information. All right, so if you haven't watched the other couple of videos I did, I made one on the standard form of a quadratic function, which is what we have here. I did another video about the vertex form of a quadratic function, which we'll also be talking about as we do this example. So if you haven't watched those, you might want to check those out because I'll be using all the information I covered in those videos to do this example here. All right, so first up, finding the vertex of this quadratic function. So first thing to do is recognize which form you have for your quadratic function, because like I said, there's two different forms. This one is what we call the standard form, which is f of x equals ax squared plus bx plus c. Right, so my a is the 2, my b is that negative 12, and my c is the 13. Right, so that's what we call usually the standard form of the quadratic function. All right, so it's 2x squared minus 12x plus 13. So if I want to find the vertex and I have the standard form, there's a formula that I need to know and use in order to get the vertex. And the formula, a very important formula to know, x equals negative b over 2a. Right, where the a and the b refer to these coefficients that we have from our function. Right, so x equals negative b over 2a, that's the formula I need to use to find the vertex. All right, well, let's use that formula. So it's negative b. Now b is negative 12, so it's negative of negative 12. Right, so just be careful with that minus there in front of the 12. That means that coefficient is a negative 12, and when I put it in this formula, it's actually going to become a positive 12 because I have the negative of negative 12. Right, so don't make the mistake that some students do where they say, oh, the formula says negative b, but b is already a negative number, so I'm just going to put in negative 12. Nope. The negative is in the formula, and b is a negative number, so that's a double negative there. It's going to become positive 12. Right, it's a little thing, but watch out for it. Right, and then that's over 2 times a, where a is 2. Right, that's the coefficient of the x squared. Right, so what I have here, negative of negative 12, is positive 12 over 2 times 2, which is 4, and 12 over 4 equals 3. All right, so the x-coordinate of my vertex equals 3. Now, that's not the whole story, right? Because the vertex is a point on the graph, and every point on the graph has 2 coordinates, right? An x and a y-coordinate. All we did with this formula is find the x-coordinate of my vertex. So don't do this and say, okay, my vertex is 3. You know, the vertex has to have an x and a y because it's a point on the coordinate plane. Right, so how do I find the y-coordinate? Well, once I get my x equals 3, I plug x equals 3 back into my function, and that gives me my y-coordinate. Right, for no matter what type of problem you're trying to do, if you're trying to find a point on the graph and you know the x, you plug it into the function for x and you do the calculation, and that's always going to give you the y. All right, so I have to find now f of 3. Right, I take my result here, x equals 3, plug it up here into my function. So it's going to be 2 times 3 squared minus 12 times 3 plus 13. And so that's going to be something that I actually reach for my calculator for. 2 times 3 squared minus 12 times 3. And then plus 13. And that's going to give me negative 5. All right. Now, you could do that by hand if you had the time and the patience to do that. You know, 3 squared is 9, 9 times 2 is 18, minus that, plus that. Yeah, you can figure it out from there if you need to. All right, so we get a y-coordinate of negative 5. So my vertex is at the point 3, comma, negative 5. All right, my x was 3. When I plug that x into my function, I get negative 5. So my vertex is at the point 3, negative 5. So when I go to graph this function, I know exactly where to put the vertex. Right? I go over 3, I go down 5. That's where my vertex is. All right, now, the next part of this part A is this a minimum or a maximum point? Well, again, if you watch the other videos that I did on quadratic functions, whether the graph is minimum or maximum, or whether the vertex is a minimum or a maximum, depends on that leading coefficient a, right? That number in front of the x squared. Remember, if that's a positive number in front of the x squared, means the parabola opens upward, and our vertex is a minimum point. If it was a negative number, the parabola would open downward, and we would have a maximum point. Right, so since we have a positive 2, that tells me that the graph is going to be opening upward, which means that the vertex is going to be a minimum point. So I'm just going to write min here under that 3, negative 5. Right, so My vertex is a minimum point at 3, -5. All right, so that's part A. Using that little vertex formula, x equals -b over 2a, plug the numbers in, simplify, get the answer, plug that 3 back in, get the y coordinate, put those together as the x and the y. All right, part B, find the x-intercepts of the graph. All right, so to find x-intercepts of the graph of any type of function, what we do is we set the entire function equal to 0, or we set y equal to 0. All right, so it's 0 equals 2x squared minus 12x plus 13, and then we solve that equation for x. All right, so this goes down now to solving a quadratic equation, which I did several videos on solving quadratic equations by the square root method, the factoring method, and the quadratic formula. So one of those methods we're going to have to use here to solve this. So if you haven't seen those videos, you might want to check them out to review how to solve quadratic equations. But this one, with these numbers here, the 2 and the 13 and the -12, it doesn't look like it's going to be factorable. And so, rather than waste my time trying to factor it, only to find out that it's not going to work, I don't have a good feeling about it. So let's just go and try to use the quadratic formula. So if you call the quadratic formula, x equals -b plus or minus the square root of b squared minus 4ac, all of that over 2a. And again, I did a video about the quadratic formula, so you might want to check that out and see how that works. But we're just going to use this here to solve this equation. All right, so what we end up with, so negative, and once again, the a, b, and the c, the a is my 2, the b is the -12, the c is the 13. All right, so -b, negative of -12, plus or minus the square root of b squared, so -12 squared minus 4 times a, which is 2, times c, which is 13, all over 2 times a, which is 2 again. And now I need to simplify all this stuff. And I missed this here. It's -b. b is -12, so it should be negative of -12. I missed that negative there, right? But luckily I caught it before I went any further. So be careful when you're plugging the numbers into the formula. Watch out for negative signs and stuff like that, obviously. All right, so negative of -12 is +12 plus or minus the square root of. Now let me see what all that stuff inside the parentheses is equal to. Let's see, -12 squared, that's going to be 144 minus 4 times 2 times 13 gives me 40. And then 2 times 2 in my denominator is 4. So I get 12 plus or minus the square root of 40 over 4. Now, if my ultimate goal here is to graph this function, so I need to know where to put the points on the graph for the x-intercept. So what I'm going to do here, rather than leave my answer as 12 plus or minus the square root of 40 over 4, because when I go to graph this, I don't know where to put the point 12 plus the square root of 40 divided by 4. Like when I go to the, I don't know exactly where that point is on the graph. So I'm going to actually calculate what this is. So I do 12 plus the square root of 40, and then take that answer divided by 4. I'm going to get 4.58 approximately when I do the plus in the middle, and then when I do 12 minus the square root of 40, and then take that divided by 4, I get 1.42 if I round it off. All right, so there's approximate x-intercepts. You know, since I am going to graph this function, I want to have numbers that I can actually put on the graph. Like, I don't know where to graph 12 plus the square root of 40 over 4, but I know where to put 4.58 on the graph, right? So it's a lot more convenient to take these and turn them into decimal numbers for the purposes of actually graphing them. All right, so those are my two x-intercepts of this graph. And then my y-intercept, which I didn't leave much room for the y-intercept down here, but luckily the y-intercept is a lot easier than the x-intercept. Remember, to get the x-intercept, I set y equal to 0. To get the y-intercept, I set x equal to 0. Right, so y is going to equal 2 times 0 squared minus 12 times 0 plus 13, which 2 times 0 squared equals 0, 12 times 0 equals 0, so y equals 13. That's going to be my y-intercept of the graph of this function. And a little shortcut to that, anytime you have any type of polynomial function written in this standard form, your y-intercept is always going to be that constant at the end. Right? Because every time you plug in x equals 0, every single term that has an x in it turns into a 0, and the only thing left is the constant, the thing that doesn't have the x. Right? So you can actually look at this and say, okay, the y-intercept is going to be 13, just because that's that number that's hanging on the end. All right, so we found the vertex, figured out that that's the minimum point. We found our x-intercept, we found our y-intercept. I'm going to pause the recording here, erase this stuff, and then put up the next parts of the problem that leads us into actually drawing the graph of this. All right, so I put all the information we already found up here on the side, because when we draw the graph of this, we're going to need to know all that information about where the vertex is and the x and y intercepts and all that stuff. So I saved all those numbers up there, and now we're going to do the next part, which is asking us to express f of x in vertex form. Right? Remember, this is what we call standard form. Now we want to write it in vertex form. And so again, I did videos on standard and vertex form, so if you haven't seen the video I did on vertex form, you should probably check that out just so you know what we're talking about here. But the vertex form of a quadratic function looks like this. F of x equals a times x minus h squared plus k, where the vertex of my parabola is at the point h comma k. All right, so the numbers that I put into my formula here, those are my vertex. Well, I already know what the vertex is, right? The vertex is at the point 3, negative 5. All right, so my h is 3 and my k is negative 5, so I can use those to write the vertex form of this particular quadratic function. So f of x equals a times x minus h. Now my h is 3, so that's x minus 3 squared, and my k is negative 5, so that's going to be minus 5. Right? The trickiest thing about the vertex form is that the number that's inside that the parentheses with the x is the opposite sign of the x-coordinate of the vertex. Right? So if my x-coordinate is positive 3, in here I put x minus 3, right? Because the formula says x minus h. Right? Whereas the k value is just normal. So if k is negative 5, then I put a minus 5 outside of the parentheses. Right? So that's almost my vertex form, but there's one other thing missing, the a. Right? So how do I figure out what the a is? Well, remember, if you watch the video on vertex form, I talked about this. The a is the same a as in the standard form. It's that leading coefficient, which is the 2 up there. So my a is 2. Right? That's why the two forms use that same letter. Right? They both use an a because it's always going to be the same exact number. All right? So there's the vertex form of this particular quadratic function. Right? So to change from one form to the other, to change from standard form to vertex form, do what we did before, find the vertex, get those coordinates, and then you just put those numbers in for h and k, copy that a number down, and then you've got your vertex form. Right? Not too bad to do that if you know what it is, if you understand what the vertex form and all those numbers actually mean. All right, so that's finding the vertex form. Once again, I'm going to pause the recording, erase this, and then we'll do the last couple parts of this example. All right, so the next thing we're going to do here is actually sketch the graph of this function. All right, and to sketch the graph, I don't need to use the vertex form, which I erased that and I didn't put it back up here. The stuff I found earlier in parts A, B, and C is really all I need to know in order to actually sketch the graph of this function. All right, so sketching the graph, let's get to it here. All right, so 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2. All right, so my vertex is at the point 3, negative 5. So I go over 3, down 5. There's my point 3, negative 5. That's the vertex. Right? I know I have a positive a value, so the vertex is a minimum point, and the parabola is going to open upward from there. My x-intercepts are at 4.58, so 1, 2, 3, 4. So about halfway between 4 and 5, I'm going to put a point for 4.58. And then 1.42, so again, about halfway between 1 and 2, I put that point for the other x-intercept. The y-intercept is going to be at 13, which I only went up to 5 here. So the y-intercept is going to be somewhere up here near this blue line, more or less, which I'm not going to reach it on this graph. But once I have the vertex and I have a couple other points, I can go ahead and sketch the graph. All right, there's my parabola for f of x equals 2x squared minus 12x plus 13. If I had enough space to put the y-intercept, I could put that point up there as well, but it's not really necessary to have all those points. All right, so the vertex, I know the parabola opens upward, so the minimum value of my function is negative 5, which occurs at x equals 3. Right, and then I have the two x-intercepts there. All right, the last part here, find the domain and range of the function. Well, looking at the graph here, the domain, well, for any quadratic function, the domain is going to be all real numbers. Right? It stretches all the way to the left to negative infinity. It stretches all the way to the right towards positive infinity. Any parabola is going to do that. Right? Parabolas always stretch out in both directions, left and right, forever. So no matter what all this other stuff is, the domain of your quadratic function is negative to positive infinity. All right? The range, though, is going to be different for each individual parabola that you graph. The range here, the y values, well, the lowest y value that I hit is negative 5. Right? That's the minimum value of the function. So it's bracket negative 5, comma, infinity. Right? The lowest point it ever hits is negative 5, and then it goes up there, and both sides go up forever, so it's going to go all the way up towards positive infinity, Remember, bracket on the -5 because that point is included. So there's a whole bunch of stuff about quadratic functions.